Greetings and salutations, magical chemists. Today we're going to talk about percent composition by mass, which is defined as, well, the percent by mass of each element in a compound. There is a law in chemistry known as the law of definite proportions, which states that a given chemical compound will always contain the exact same elements in the exact same ratio by mass. The formula for calculating the percent composition of a given element in a compound is not on your formula chart. However, it is pretty straightforward. You just take the total mass of the element in a compound and divide that by the total mass of the entire compound, times 100 to make it a percent. Let's take a look at some example problems for percent composition. In the first problem it says, find the percent composition of each element in the compound copper 1 sulfide. Now, it's important to recognize you can't actually do percent composition unless you can get the mass of the entire formula, and you can't do that without a formula. So our first step is to write the formula for copper 1 sulfide. You should totally try that on your own first, and when you're ready to check the answer, unpause the video. First, remember that the Roman numeral tells you the charge on the copper ion. So this is copper with a 1+ charge. Sulfide, of course, is sulfur with a 2- charge. So now we need to make sure that the charges, when added together, combine to 0. That means I must need 2 coppers for every 1 sulfide ion. All right, now we have the formula. Now we can do the math. They asked for the percent composition of each element. So there are 2 calculations, one for copper, one for sulfide. On the bottom, we need the mass of the entire compound. That's the molar mass of the compound using the weights from the periodic table. On the top would be the molar mass of just copper, but times 2 because there are 2 coppers in this formula. And of course, times 100. So then we just need to go to our periodic table and plug in the numbers. So go ahead and try this on your own, and when you're ready to check the answer, unpause the video. Hopefully you found that there's 79.86% copper. Now, we need to do that for sulfur as well. But, there are 2 ways to do it. You could, of course, recognize there are only 2 elements. So when I add them together, they have to be 100%, and just take 100% minus 79.86. However, if you made a mistake in your first calculation, you won't ever catch it if you do it in that method. So I actually tend to do the math percent composition for a second time because then I can check my work and make sure that they add up to 100 like they're supposed to. So take a moment, try the calculation for the percent composition of sulfur, and when you're ready to check your work, unpause the video. The easy part is that the mass on the bottom is still the same, and there's only 1 sulfur. So I just have the molar mass of sulfur on the top. And now I can double check that when I add these 2 values together, they do indeed equal 100%. Next, let's look at percent composition for a hydrate. This problem is specifically looking for the mass percentage of water alone in this given hydrate, sodium carbonate decahydrate. And look, we were nice. We even gave you the molar mass. So you should totally try this. And when you're ready to check your answer, unpause the video. In this case, because you're looking for the mass of the percentage of water, you need the mass of water on the top, but you have to remember and multiply it times 10 because, of course, it's a decahydrate. Other than that, you're just doing the same old calculation. Nothing tricky here. All right, next problem. In this problem, we're going to use the law of definite proportions. Because it says when ammonia is formed, 1 gram of hydrogen reacts with about 5 grams of nitrogen. So how much nitrogen would I need if I was actually reacting with 2.5 grams of hydrogen? Well, you can set this up. There are multiple ways to solve this, but you can set it up as a simple proportion. I know that for every 1 gram of hydrogen, 5 grams of nitrogen will react. So if I've got 2.5 grams of hydrogen, how much nitrogen will I need? Well, notice the hydrogen increased 2.5 times. It would make sense the nitrogen would increase 2.5 times, which is what you get when you solve for x. And so you would need 12.5 grams of nitrogen to react with 2.5 grams of hydrogen to form ammonia. All right, we have 2 more practice problems. I'm sure you're excited to see that they are multiple choice, calculator-free math. So let's take a look. So we're looking at Lake Superior, which is the largest lake in North America. And it contains, I'm just going to believe the people who told me, 1.2 times 10 to the 16th kilograms of water. Wow. Well, if that's the case, they want to know the mass of hydrogen that's contained in Lake Superior. If you're feeling brave, go ahead and try this problem. If not, I'm going to walk you through how to do this, because this one's a fun one. So in this case, even though they're looking for a mass of hydrogen, the easiest way that I know is to do this as a percent composition calculation. Shouldn't surprise you, this page is about percent composition. So what we need to do is figure out what is the percentage of hydrogen out of the entire mass of water. Well, it's H2O, so I just take 2 times the mass of hydrogen, divide by the mass of water, and then I do it without a calculator. It's going to be great. We are going to round to make our lives easier, so we're going to call the mass of hydrogen about 1, and the mass of water about 18. And of course, I'd have to multiply by 100 to get a percent. So I've got 2 out of 18, 2 divided by 18 times 100, which is honestly like 2 out of 20, which is kind of like 1 out of 10, which gives us about 10%. Well, that's a happy answer, because that means we just need to take 10% of our entire mass of water, and that'll be the mass of hydrogen. Well, 10% of something is just like multiplying by 0.1, which of course is just like moving the decimal place over 1 place, making it smaller by 1 degree, which means 1.2 times 10 to the 15th kilograms will be the mass of our hydrogen. If you weren't sure how to multiply 0.1 in your head, remember that 0.1 is just 1 times 10 to the negative 1. So when you're multiplying exponents, you just add them together. Notice 1.2 times 1 is of course just 1.2. And then I've got 16 plus negative 1 gives me 15. Easy peasy. You might be thinking, wait, if that's so easy, that answer isn't there. Remember, we totally rounded things, so we're looking for the closest answer. So our best answer choice should be C. All right, one more to go. Got a 150 gram sample of glucose, in which case there are 60 grams of carbon. So how many grams of carbon are there in a 300 gram sample of glucose? You should try this. It'll be amazing. And then when you're ready to check your answer, unpause the video. So this is another proportion. So we're just solving for x, but without a calculator. So we have 60 times 300 divided by 150. Well, 150 goes into 300 twice. So now I just have 60 times 2. And boom, I'm done. And there you have it. This is the end. So thank you for playing with the glories of chemistry.